Okay, today is May 24th, 2011. You guys are on text page 411, blue notebook page 345. We're doing lesson 7.4. I'm going to do a quick, very brief recap of the last two lessons we went over. We skipped 7.1. Quickly, the first three rules, we have our multiplication rule. I'm just going to put an M. The rule is if we are multiplying two numbers with the same base and different exponents, we keep the base the same, and we add the two exponents together. That's our multiplication rule. That's when you multiply. It has nothing to do with adding numbers together with the same base or subtracting them. Okay? Some of you would have made this mistake. I've seen this before. You'll see x power of a plus x to the power of b. There's no shortcut to that. That ends up being whatever this equals, you bring it down. Whatever this equals, you bring it down, and you add those two numbers together. There's no shortcut rule where you add exponents together if you're adding them. It only works for multiplication. Okay? Division rule. Same idea. If we have two numbers and the bases are the same with two different exponents, or it could be the same exponent, the quick way to evaluate is keep the base the same and subtract exponents. Same idea, if we have subtract x to the power of b, there's no quick way. Solve, and subtract the two numbers. Okay? Don't get those two things confused. Multiplication gets us to this. Division gets us to this. Adding and subtracting are completely different. Okay? Please don't get that confused on the test if I give you an addition question with numbers with the same base. And finally, our power rule is just that if we have an exponent to another exponent or to another power, we just multiply the two exponents together. So a times b. Can't think of a way that you could mess that up. Some people may get this confused with the multiplication rule and add them together. This is when we have a power of a power. Okay? Any questions about that? Okay, that was lesson 7.2. Lesson 7.3 was making exponents. Whoa, what happened there? Making exponents positive and negative. So, if I have x to the power of negative a, that is also equal to 1 over x to the power of a. Same idea goes if I have 1 over x to the, let's just say, negative b. I'm going to change the exponent. That is also equal to x positive b. That covers all of it. One rule, two. So if any of the questions ever ask you to put the answers in positive exponents, so for example, if I have 5 to the negative 2, and they say they want a positive power, they want you to invert this, so it becomes 1 over 5 to the power of 2. Okay? That would be making the exponent positive. So please read the questions carefully. If anything says power, positive power, make sure you flip it if it's a negative. Questions about that? One other rule. You can tell me what x to the power of 0 equals. That's supposed to be 0. Anything to the power of 0 equals 1. Anything. 52 to the power of 0. 1. You want me to keep going? You got 2 more? Okay. 19 to the power of 0. 1. Tom L to the power of 0. 1. Got it? Does that make sense? That was the other rule we went through. Anything to the power of 0, 1. Make sure you remember that. And today's stuff. Okay, finally. Let's start with today's stuff. So we'll go to another page. Okay, today we're dealing with radicals. Okay? Technically an exponent is a radical, but we're going to be dealing with exponents that aren't whole numbers. So a fraction, let's say. So the rules they've given us, let's make sure they use the same letters. They have b to the power of 1 over n is equal to the nth root of b. I know I'm using letters, so that's very confusing. I have no idea what that means. Let's give an example. Let's say I have 9 to the power of 1/2. What they're asking for is the second root, which we know as the square root, that's what we call it, of 9. So this little 2 here tells us how many times we have to multiply a number by to get this answer. So I need to multiply a number by itself twice to get 9. Anyone know what number that is, Ian? 3, that's right. The square root, oh, I didn't want to use that. Oh, geez. There we go. The square root of 9 is 3. So in other words, if I multiply, we'll do it in red over here. 3 times 3, I'm going to get 9. Okay? Let's do another example. Let's say, example 2, I have 27 to the power of a third. When I go to set this up, I have 27 to the third root. Whatever number is on the bottom, I bring over there. So we have a 3, so we're asking for the third root. Does anyone know what that might mean? Not quite. Close. Good guess. 3 times. I've got to multiply a number by itself 3 times. Ian. 3. That's right. So if I multiply 3 by itself 3 times, we'll get 27. I used that number purposely. So 3 by 3 by 3. We know 3 by 3 is 9, and 9 times 3 is 27. So the answer to this would be 3 again. I'm purposely using those numbers. So whatever the fraction is, as long as it's 1 over that, they're looking for that root. So for instance, we had 1 over 2. So they're looking for the square root, or the second root of 9. We had 1 over 3. We're looking for the third root of 27. I could have 1 over 80, and I'd be looking for the 80th root of some number. That becomes quite difficult. But do you guys understand that idea? We'll do some more examples, don't worry. That's the first rule. Okay? So that's where they had 1 over n. What was the other example they have? M over n. Oh yeah, and where b is equal to 0. Also, this only works when b is not equal to 0. Okay? Second rule we'll go through today. Same idea, b to the power of m over n. So in this case, they've replaced 1 with the letter m. And what they're asking for is the same idea, the nth root of b to the power of m. I'm going to do some of those examples too. So let's say I have... Are going to be word questions? Yeah. There's 7 lessons in this unit. So we still have to do word problems. We haven't got to them yet. Okay. Example 3. 27 to the power of 4 over 3. Okay? There are 2 ways we can do this. I'm going to bring the calculator up so that you guys can see all this. Okay. First thing we're going to do is we're going to rearrange this into a root, just like we were doing before. So, in other words, what I mean is I want it to look like the example they've given us. So, in other words, I'm looking for the root. Because I have the 3 on the bottom, it comes over here. I'm looking for the third root of 27, which is already a question we've already answered. The only difference is this 4, this 27 is now to the power of 4. Okay? I know I didn't draw that very nicely. which means I can go about this two ways. I can split this into two different steps. I can first, if I like, do it in red. I can find the third root of 27 first, and then get that answer to the power of 4. Or my other option to solve this would be to find 27 to the power of 4 first, and then find the third root of that number. There's two roots to this. I'm still going to end up with the same idea. So let's do the one we did in red first. You guys will be allowed to use your calculators for this, but you need to know how to type it into your calculator. Okay? So there are a couple ways you can do it. Usually there's an X number button. Okay. One way we could do this is I can type in the number 27. This gives me to the power of. So if you have like a roof-looking button, or like a small hat, you hit that, any of the next numbers I put in are going to be the power of. So this question says to the power of 4 over 3. I'm going to first solve. First thing I'm going to do is I want to solve for the root 3 first, okay? So that means I'm going to be looking for 1 over 3. So in brackets, 1 divided by 3 end bracket. You guys can see in your calculator exactly what you're typed out. It's going to be much easier to do this unit. Okay? So this says 27 to the power of 1 divided by 3. My answer is 3. We'd already found that out earlier, which is good. So I now have 3, and now I'm going to solve for my power of 4. So I can take that answer from before to the power of 4, 81. Now I could have gone the other route, which would have given me a much larger number, and I'll definitely need a calculator to solve. I'm going to do the other route first. I'm going to do the power of, so I'm going to do 27 to the power of 4 first. Okay? So this is the blue step. 27 to the power of 4 first gives us a very large number. Ooh, what's all I want to do? We're still going to find the third root of this number, 5, 3, 1, 4, 4, 1. Okay? I got to find the third root of that. So I'm going to put that to the power of 1 divided by 3. If you're putting something to the power of 1 divided by something else, so a fraction, make sure you put it in brackets. If you don't put it in your brackets, the computer is going to read it as whatever number to the power of whatever number is on top of the fraction. So if you have to the power of, we have a 1 here, it would read it as this answer to the power of 1, and whatever that is, divided by 3. If you're going to put it as a fraction exponent, you have to put it in brackets, so the computer knows to do the division of the fraction first. So look for the answer to that, and it's 81. Look at that. Smart that computer is. So, like I said before, there's two ways you can solve that. I can find the power first, or I can find the root first, depending on which route I want to go. Okay. Some of your calculators, guys, are going to have a button that says probably like an X and a square root. What you have to do there first, if you have this looking button, something that looks like this, you got to put the number first. So if I'm looking for the third root, I put the number 3. Then I push number 3 first. Then I push that button. And then whatever number. So say we were doing 27. So that would be the order of the buttons. If you have a button that looks like that, there's an X in front of a root sign. You got to put whatever root you want first. So we were doing the root of 3. Hit the number 3. Then that button. Then whatever you're trying to find the root of. I'll come around and help you with your calculators, okay? I want you to try it right now.